Hey guys, today we're going to cover topic 1.1, which talks about points, lines, and planes. All right, first we're going to talk about a point. A point is a location. It has no shape or size. And it's important that you understand to always use a capital letter to name a point. So for example, this point is called point A. All right, now a line is made up of points. And any 2 points can form a line. Okay, so remember, again, all it takes is 2 points. If you could put 2 points anywhere, it doesn't matter where, you can always connect them. So again, any 2 points form a line. And also, a line has no thickness or width. Okay, and there are 2 ways that I'm going to show you how to name this. The first one is, if you notice here on this example, there's an N. The line itself is called line N, okay? But also, you can take any 2 points, which the only points here are the X and the Y, and you'll put them in capital letters how they are, and you're going to use this notation. Okay, you're going to draw a line on top of it. So line X, Y, you don't have to write line, okay? You just have to, this notation here tells you that it is the line. All right, now let's talk about collinear points and non-collinear. Okay, so collinear, it means that they lie on the same line. So for example, X and Y are collinear. They're on the same line. But what if I had some other point, and I'm going to just call it C. Okay, notice how it's not on the same line. So I can draw another line, and I'm going to choose Y and C. Okay, but see, C is not collinear to X. It is to Y, but not to X. So therefore, in the example that I showed you, X, Y, and C are non-collinear. Now let's talk about a plane. A plane is a flat surface made up of points. Think of it as your sheet of paper that you have. And you need at least 3 points to make a plane. A plane extends indefinitely in all directions, okay? And we name a plane by any 3 non-collinear points on the plane, okay? So this is very similar to the line. Notice how there's no point here. Whenever it's just like a different scripted letter, then that is labeling the plane. So P is the name of the plane. We can call it plane P. And again, we can use 3 non-collinear points. So K, J, and L. You can do that in any order that you want. It doesn't really matter. So another way we can label this is plane. And I'm going to put this in alphabetical order. J, K, L. And there isn't a special notation like there was for the line. So if we go back to the line, remember how we used this line on top of the letters? For the planes, you can't really do that. So you're just going to have to put plain JKL or whatever letters it's giving you. Now, coplanar points are points that lie on the same plane. So for example, K, J, and L, they're all on the same plane. Therefore, they are coplanar, on the same plane. Non-coplanar points, they don't lie on the same plane. Okay, and you have to have at least 4 because you need at least 3 for them to be coplanar. So let's say I have some other point here, Z, that's not on the plane, and it's kind of hard to kind of grasp that right now, but it'll make a lot more sense once we start getting into this. But Z is not on the same plane, so therefore they are non-coplanar. 2 lines always intersect at a point. Okay, and 2 planes always intersect at a line. Okay, the reason that planes cannot intersect at a point is because there's multiple points. You see, we have this endpoint here, this endpoint here, and all of the infinite points in between. So therefore, it has to be a line. So here are just some practice problems that we're going to work on. Part A on the first one says to name 4 collinear points. Remember, think of it like same. So same line. So 4 points that are on the same line. I notice H, N, K, and I. And you don't have to put points. You can just remember capital letter is the main thing. H, N, K, and I. Now, I don't want you to get confused thinking that M, N, O, and P could have been one because P is not a point. Remember, if there's no point next to it, it's naming the line. So actually, P represents the name of this line here. All right, now it's asking for a line that contains point M. So here is point M. Now, remember, we just talked about the line. It's called line P, right? But remember, there was also another way to name the line. All you need is 2 points. So you could have called the line, and you don't have to do this unless you want to, but you only have to choose one way. There are multiple ways you can do this. So line MN, so those are 2 points, and you have to use the right notation for that. Whoops, I put 2 N's. MN. So that's also the name of the line. You could also name it NO because O and N are on the same line. You could have also said MO. These are all the ways you could have named the line. But remember, you only have to pick one. Although I would choose the easiest way if there's already a letter, okay, in lower script and it's already named the line, then that's probably the easiest way to go about it. Part C wanted a line that contains H and K, so I named it line R. Okay, there, that R represents that line. Part D wants another name for line Q. So we actually just talked about that in Part B. So JK, and remember, there's other letters you could have used as well. The intersection of lines P and R. Okay, well, the intersection of a line is a point. So let's look at P and R. So here's line P, and here's line R. The intersection is point N. Okay, part A for number 2 is asking for a line containing point F. So I'm thinking, let's see, it's line J. Remember, if the line's already named, just go ahead and use that lower script letter. All right, number 2 wants you to find another way to name line K. So again, 2 points. I'm going to pick B and E. So line BE, don't forget that line on top of it. Now you're probably wondering, well, did she not pick C because it's not on the same plane? It doesn't even matter if it's not on that plane. You see how C lies outside of the plane? All that matters is that C goes through the line. So yes, you could have still used C. You could have used EC to name the line. We don't care about the plane. We're just focused on the line. Part C says a plane containing point A. So let's see. If you notice here, M, there's no dot next to it. So M is actually the name of the plane. So we can call it plane M. And this is just going to take practice, guys. But remember, there's also another way to name it. Just pick 3 points because it takes at least 3 points to make a plane. So I could have said plane, let's see, A, D, F. You could have used E, D, E, F. You could have said A, E, F. It doesn't really matter. Just pick 3 points that are on the same plane. An example of 3 non-collinear points, so not on the same line. What? I chose D, E, and A because those are not on the same line. Now remember, D and E are in the same line. Those are collinear. But if you're talking about all 3 points, then altogether they are non-collinear. I hope that makes sense. So we talked earlier about how 2 lines intersect at a point and 2 planes intersect at a line. But we haven't really talked about the intersection of a plane and a line. So a plane and a line intersect at a point. Okay, so let's look at this. The plane and line K intersect at point E because E is the only point in that line that is also in the plane. All right, number 3, part A wants us to name 3 coplanar points. So 3 points that are on the same plane. It doesn't matter which 3 points you pick. I picked V, Y, and X. All right, part B is asking for a plane containing point X. So you just have to name the plane. It's already labeled for you, plane R. Part C is asking for the intersection of plane R, which is like that flat piece of paper looking plane, and plane ZVY. All right, so if you ignore everything else and just focus on the two planes, I did one in blue and one in red. Notice how where they cross is this line segment. So before we talked about how two planes intersect at a line, it could also be a line segment because a line segment is a part of a line. And to label that, we're going to put the little bar on top of the letters, except we're not going to put the arrows. Okay, so with the arrows, it is for a line. With just the bar, it is a line segment. Part D is asking how many planes appear in the figure. Now, if you notice, the base of that pyramid is on this plane as well. So we don't have to count that twice. That's only once. So there's your one, and then all the faces. So there's another 1, 2, 3, 4, and this one here in the front, this triangle. So we have 5 total planes. And last part, part E, wants to know how many planes contain point W. So W is right here. My work is kind of sloppy. So we have the big plane. So there's 1. And W is also contained in these 2 planes. So 2 and 3. We have 3 planes. Number 4, part A says the intersection of lines L and M. So the intersection of 2 lines is a point. And that would be point E. All right, part B says another name for plane Q. Okay, so just pick 3 points on the plane. And I just picked E, F, and G. All right, part C says are points D and E collinear or coplanar? Well, to be coplanar, you need at least 3 points. Okay, so that leaves us with collinear, which means they have to be on the same line, which in fact they are. And lastly, part D, how many times do planes Q, so it's supposed to say do. So how many times do planes P and Q intersect? So notice how they do not intersect. They seem to be parallel. Now we can't verify that for sure, but in this specific example, in this picture, they are not intersecting, so we're going to say 0. All right, guys, that's all I have for 1-1. Thanks for watching.